Hi, I'm Audra. We're now getting into the business of analyzing our data in this, our fourth podcast. In each of the test analysis podcasts, we're going to focus on a single test. As with the other podcasts, there are two assumptions that we need to have before we move forward. First, you're already familiar with research methods. This podcast isn't about teaching you what research methods are and how to approach research. You should already know that before you start watching these. Second, you have a data set that you're trying to work with. This series is designed so that you watch some podcast material and then try it yourself, even pausing when you need as you go. So let's move into the fourth installment in our series, Running Paired Sample tTests. In this podcast, after a brief introduction to paired sample tTests, we're going to get straight into the demonstration of how to run them and how to interpret them. So you'll need to make sure that your data file is set up correctly, that your factor analyses are run, and that you've compared your data analysis and completed your data analysis plan, identifying which tests you need to use to analyze each of your research questions and our hypotheses. If you don't have all of these things accomplished, go back to one of the starter podcasts 1 through 3. So here's what we're going to be covering in this podcast. In podcast 3, we established that paired sample t-tests were a good way to see if there's a change or difference between two related data sets. For example, in a lot of experimental research, we highlighted that if we have a pre-test and a post-test measure of the same concept, we may want to know, at least as a starting point, whether there is a meaningful or statistically significant difference in people's attitudes from the pre-test measurement to the post-test measurement. They also work really well if you're directly comparing two different groups' responses to the same question. So here we have our data set open. And because you're not doing anything with the data file and just running the statistics, it's easier just to keep the spreadsheet minimized and work directly off your output. Our output has opened, and let's make sure that we're saving this as our tTest file now. So I had already pre-saved it as tTest. Do the quick save, replace, yes. Now, remember from our data plan that our t-test was for research question 1, looking at whether different types of airline crises would affect people's attitudes towards flying. We were comparing whether there were purposeful crashes to mysterious disappearances to infectious disease. With paired sample t-tests, you can only compare two at once. So we have 3 sub-questions comparing each of these, and that's where we're starting with our tests. So we go to our SPSS, we go to analyze, then we go to compare means, and over to paired samples t-test. Now let's move this over, and let's make it a little bigger so it's easier to see. And so what I'm going to be looking for are my particular experimental conditions, or in this case, the multiple measures based on the 3 different experiences. So here's the first, German wings, the purposeful crash, and we want to compare that to the missing crash attitude. So my attitude has not changed. And then we want to compare these we want to go back to the German wings, because our second comparison was German wings compared to the infectious disease. My attitude has not changed. Then we need to cover our last comparison, which is the Malaysian Airlines, so the missing one to infectious disease and my attitude. Now, once you have these put in, and keep in mind that these variables were already computed. So this is another example where you go through the process sequentially and fully, and it makes it a lot easier at this point. So we have all 3 of our comparisons in. There's nothing else that we actually need to do in order to run our t-tests. So we just come down and we click OK. and we see the output boxes. Now, for now, don't worry about this first box. We'll come back to that one later after we see what we have and for reporting our results. Likewise, you can just ignore the second box. It's not information that we're interested in and doesn't really help us with this particular analysis. So the one for t-test of interest is the third box. Let's take a look at the box from the left column all the way to the right. So in the left column, all that tells us is the comparisons that we made and in what order. So you have these three comparisons as a quick reminder. Again, this is why good labels on your variables in your SPSS file become quite helpful as you start to do the analyses. Now, in the next 5 columns, it provides information that SPSS used to run the test, but it's really not information that we need. Basically, SPSS is just showing its work. Now, these next 2 columns, the t and the degrees of freedom, are important values, but they're the ones that we ultimately will have to report. Yet, without knowing the last category, the significance one, we can't really interpret what these mean. Are these findings significant from the t column? Well, this is where our last column comes in. We go all the way to the right for our significance test, or our p-value. Now, remember, when we're looking to see if our results are significant, we look to see whether the p-value is under 0.05. So if we take a look at the right column, are all 3 of our tests significant? Yes, all 3 tests are significant. Good news. Now, we know that they're significant, but now what do we do with them? Well, to understand our findings, let's go back up to our first box, where it actually tells us our means. So, research question asked if there was a significant difference in attitudes towards flying between a purposeful crash and a disappearance, between the disappearance and infectious disease, and between the infectious disease and the purposeful crash. Basically, big picture is, does the type of crisis or the type of airline disaster influence people's attitudes about flying? So, we know that there are significant differences now. Now, how do we interpret our findings? Very simply, the most basic answer to our question is that different types of crises affect people's attitudes towards flying differently. Now, if we take a look at our means, the highest mean was the 4.93 for the purposeful crash. The middle mean was the 4.70, and these are all on a scale of 1 to 7. Was fairly neutral, but still more so towards the other side, was the disappearance. And then the lowest one was the infectious disease, the 4.64. Now, keep in mind what the question was, that there is no change in the attitudes. So the higher the number in this case, it means that people don't see a change in their attitudes. So how do we interpret these results? Quite simply, infectious disease is the most likely of our 3 types of crisis to change people's attitudes about flying. The mysterious disappearance would be our second, and the purposeful crash would be our least likely to change people's attitudes about flying. So, aside from reporting the numbers, which we'll address in a moment, this is really the narrative of your results, what you report in the results section. So as a non-mathematician, I find that as soon as I can tell the story about the data and get that into a written summary, it's a lot easier for me to understand what I've found, reflect on it, and then think about the implications of the data for theory and practice. Those implications are the basis for your discussion section. So what I like to do is to get the narrative written as I go along. I complete the tables, and then in my Word document, as I'm translating my findings, I usually bullet out my initial thoughts about the implications towards theory and practice. This helps form the basis of my discussion section, and it makes the writing process a lot more efficient. What it also means is that once I have translated this data, these numbers, into the tables and into the results in my Word document, I don't have to look at these tables anymore. So let's be sure to save this, just in case we had to come back to it. But now let's focus on how to actually report your findings. So, when you're reporting your findings, there are 3 things that you need to be able to report. 3 key pieces of information that you have to report in your results section. First, you need to tell the reader what type of analysis was conducted. If you don't, your results don't make as much sense. So in your method section, you will have already provided a justification for the tests that you've run for each research question or hypothesis. So in the results section, you offer a quick summary to remind your reader of why you've run the particular test that you have. The second key piece of information is that you want to tell your reader whether or not there were any significant differences between the means. To do this, you report the mean and the standard deviations. What you'll find in quantitative research is that the results section is kind of a formula. Once you have the basic structure of each of your sentences, it is simply about plugging your data into each of the sentences. The results section isn't the most beautiful prose that you'll ever read, but it's essential. It's essential information that you're communicating about your findings. And then the third piece of information is that you report the t-test itself. So you'll report the degrees of freedom, the t-value, the significance, typically referred to as the p. So in our research plan, we identified these questions that we should ask and to use our paired sample t-tests. And we've been looking at these throughout. I like to keep them going, and I like to keep my research plan up because I find that it makes it a lot easier to keep on track and to keep focused. So from here, reporting your findings in your results section and creating your tables is just really a matter of plugging the numbers from your SPSS output directly into some basic stock sentences and table layouts. So let's do that for our first research question. So your full sentence for your first t-test would look something like this. There was, or not, a significant difference between the means for your variable name and your second variable name. You report the numbers and the value. So let's go ahead and do that. So let's edit our sentence. So there was a significant difference between the means for attitudes towards flying between a purposeful crash. So we put in our mean right here of 4.93 with a standard deviation of, and remember we round just to 2 numbers, 1.95, and a mysterious disappearance which had a mean of 4.70 and a standard deviation of 2.09 with a t-value of, we scroll back down here, so our first t-value was the 4.84, a t-value of 4.84, and significance of 0.00. Now, there will be numbers out here somewhere. So if you have a number that is really significant, p equals 0.000 on your output, instead of p equals, you would go p, the less than sign, 0.00. Now, the way to report this, however, so on our third comparison between the infectious disease and and the mysterious disappearance is a 0.038. So here we would go back to our p equals, and we would put 0.04. But so for this one, let's leave it as p is less than 0.00. Always rounded to the 2. So for our first comparison, this is the sentence that you would put directly into your results section. There was a significant difference between the means for attitudes towards flying between a purposeful crash and a mysterious disappearance, with the numbers being reported. You can add in another sentence that would be something like a purposeful crash affected attitudes to a larger degree compared to a purposeful, I have said that backwards, a mysterious disappearance than compared to a purposeful crash. So in those two sentences, if you type those into your Word document and then you create your table, you could literally copy and paste those two sentences for your comparison. Write those two sentences the same way for each of your comparisons, and you basically are writing a draft of your results section all together all at once. Now, t-tests, if you have a small number of t-tests, so we only have 3 for our research question 1, you can report them directly in text like this. What you could also do is, instead of this kind of a sentence, what you could write is like we described with our narrative, that there were significant differences between each of the 3 types of crises. That infectious diseases cause people's attitudes to change the most, followed by mysterious disappearance, and the least impact on people's attitudes towards flying was the purposeful crash. If you wanted to report that sentence, that would be just fine. However, if you did that, then you would need to report a table. And this is on something that's quite short. When you only have a few of these t-tests, it is entirely your preference whether you want to report it like this in 6 sentences basically, or do the narrative explanation and then put in the data. That is entirely up to you. So let's go back. If we're going to create the data, this is a basic t-test table that you would put in. So let's go back to our data and let's fill it in for this particular test. So our mean on the purposeful crash was, again, 4.93. And then our mysterious one was a 4.70. And we enter it again, 4.93. Oops. And we compare that to our infectious disease, which was 4.64. And so again, you see where I'm taking these from this column and simply plugging them into this column. So then we go 4.93. And that one was an error. So these are what you have to be careful when you're translating, is that you don't make errors, or when that you do, you keep them consistent. So this is why if you have them laid out in this order, report them in the same order. So we go 4.93 to 4.70. Then we go the purposeful crash as the second one is 4.98. The reason there's a difference in those means is that there was a bit of fluctuation in how many people would have responded to the question, and so the test itself is comparing, and then our infectious disease, and then our mysterious disappearance is 4.76, and our infectious disease is 4.64. So that's one of the tricks to make sure that you're correct in how you lay everything out, is to build your tables in the exact same order. So we go through our standard deviations, so we just take everything from this column and translate it directly into this column. So we go 1.95, we go 2.09, then 1.95, 1.99, 2.07, and 1.98. Now our t-values, we only need to enter once, obviously, because that's our it's only for the two comparisons. So we scroll down over here, move that over. So our t-value for our first comparison was 4.84. For our second comparison was also 4.84. And for our third comparison was 2.07. Enter in the p-values. And in this case, when you're doing the table, you do just put in the 0.00 and then 0.04 for the last one. And there you have the running of your t-test, interpreting it, and then making sure that you're reporting it correctly. Look at that. We got through our first set of data analysis and no one had to do any math. We just had to take a look at our results, tell a story from them, and then take the information that was relevant off of our SPSS tables and to put them either into sentence form or into table form. Now, again, you can choose how you want to do that. Now remember, good research is really about good storytelling. This is true no matter whether observations or interviews are forming the basis of your narrative or numbers are. And that concludes our fourth podcast on paired sample t-tests. Coming up in our next one, we took a look at ANOVA and ANCOVA.